When I was growing up, my dad had a 386 computer that I used to play around on. We also had WordPerfect 5.1 installed on this computer, and I would sometimes use it to write up my assignments for school. To start, you would cd into the WP51 directory, and then run WP, and you'd be greeted with this very blue screen. Something that really fascinated me as a kid was that I could press and hold the Alt key on the keyboard, and then type a number on the numpad, say 1, and this smiley face would appear. Alt 2 was a filled-in variation of the smiley. Alt 3, 4, 5, and 6 was a heart, a diamond, a club, and a spade. And it didn't stop there. I eventually learned that there was even more symbols available if I held Alt and typed longer sequences of numbers. For example, Alt 130, 136, and 138 were various accented E's, useful for my French assignments. As a kid, I spent a lot of time typing random Alt numbers just to see what I'd get. If you type Alt 1281, you get another smiley face. I was surprised that there were different ways that you could get the same symbol. These Alt sequences would also work in other programs, like Edit. We can type Alt 1, 2, 3, 4, 5, and 6, and we would get the familiar sequence. As a kid, I was exploring a character encoding called Code Page 437, the original character set of the IBM PC. This code page has a total of 256 code points and includes various arrows, symbols, punctuation, and even some characters for building text-based UIs. When I was typing Alt sequences longer than 256, it was wrapping around. So for example, Alt 257 would also be the smiley face. Let's save this file to the DOSBox folder so that we can use it later in this video. I later discovered that there were other code pages that you could switch to. For example, here is code page 850, which is largely the same as code page 437, but opts to have some additional characters instead of the UI and mathematical symbols. The majority of these code pages have a couple things in common. They typically use 1 byte to encode 1 character, which is why they all have 256 code points. And they largely aim to be compatible with ASCII. That's why the characters in this range 0x20 to 0x7e are the same across code pages. As PCs moved into the Windows era, they started using the Windows 1252 code page, which altogether drops the text mode UI characters. Nowadays, UTF-8 is the most widely used character encoding, but you can still create the characters from those older code pages. For example, in Notepad, if we type Alt 1 and Alt 2, we get the smiley faces. If we type Alt 3, 4, 5, and 6, we get heart, diamond, club, and spade. These are all being taken from code page 437. We can also produce characters from Windows 1252 by prefixing the Alt sequence with a 0. So for example, to produce the copyright symbol, we need the decimal version of A9, which is 169. So Alt 0169 is the copyright symbol. Let's save this file to the Winbox folder. Notice that the default is to use UTF-8 encoding. Anyway, the purpose of that story, aside from being interesting to me, is to introduce you to a little hex viewer that I made for Jupyter Notebooks called Hexly. A hex viewer is a tool that enables you to see the contents and structure of binary data. We'll start by importing Hexly. Next, let's use Hexly to show a hex view of the bytes 0 through 255. This area here shows you the bytes of the data. Each byte is represented by a hex value from 00 to FF, and every row shows 16 bytes at a time. This area over here shows the data encoded as ASCII. Hex viewers usually operate on files. Hexly is different in that it works in a Jupyter Notebook instead. So, in the previous section, we ended up creating 2 files. Let's open the file we created in the Windows box, which we called winbox.altchars.txt. We know that this file was encoded as UTF-8, so Python can directly decode it. We can read this file in text mode, which is indicated by this R here. And if we evaluate the variable, we get back the string we typed in Notepad. The second file was saved to DOSBox.altchars.txt. Now this file was not encoded in UTF-8, so when we open it, we should read in binary mode, indicated by RB here. If we evaluate the variable, Python gives us a byte view of the data. Each hex value is represented by \x followed by 2 digits. We can also use Hexly to view the byte data. By default, it assumes ASCII encoding. We can change the encoding to code page 437 by setting the encoding parameter. And if we reevaluate the cell, we can see our original characters from DOS. Now, one last demo. Cypherly encodes its payload in the URL using a URL-safe base64 encoding of a message pack binary. Let's use Hexly to take a look. So first, let's encode a secret using Cypherly and then copy the ciphertext. Now, back in Jupyter, we can use base64 URL safe B64 decode to decode the ciphertext. Here we can see the Python byte string. And here is the hex view of the data using Hexly. Now we can clearly see, or at least somewhat see, that we have our three fields, salt, initialization vector, IV, and ciphertext in this payload. If we look up the message pack spec, we'll see that 83 encodes a map of 3 elements. A4 encodes a string of length 4, which is salt. C4 encodes a binary string whose length is 16 bytes, 10 in hex. After 16 bytes, we see A2, which encodes a string of length 2, which is IV. We see C4 again, encoding a binary string whose length is 12 bytes, 0C in hex. After those 12 bytes, we see AA, which encodes a string of length 10, which is ciphertext. We see C4 a third time, encoding a binary string whose length is 20, 14 in hex. The remaining 20 bytes is the encrypted ciphertext. So to get that demo of WordPerfect working, I used a free tool called DOSBox, which emulates a DOS environment on my Mac. I'll admit that it was really fun strolling down memory lane. If you enjoyed that too, hit the thumbs up. Hexly is available on PyPy. You can install it by typing pip install Hexly and then use it the way I did in this video. As usual, instructions and all materials used to create this video are linked in the description. So check those out if you'd like to learn more. This week, we hit our milestone. We now have 2 to the 7 or 128 subscribers. The next milestone will be 2 to the 8 or 256 subscribers. Let me know in the comments how you'd like to celebrate the 2 to the 8 milestone. More videos about Cypherly and other things that pique my interest will be landing in the near future. Subscribe so you don't miss those videos. Thanks for watching, and I'll see you in the next one.